Okay, so here we have a package that came from Oregon, and this is the HP Spectre X360, the 13-inch. USB-C has failed. So the first USB-C port has failed. The charging connector directly below has almost completely failed. This is very close to total failure. So let me take a few minutes to remove the board and I'll be back. Okay, so here we have the board. Now I did try both ports and both of them did not power on the computer. And we're gonna try it again right now. So this is the cord right here. If we plug the cord in the first USB-C port, we should get a light here. There's an LED here that should light up, which indicates that the cord is powering the board on. We do not see any light. Let's try the second port. The LED did not light up either. So both ports are not sending power in. Now each USB-C port on this board has a USB-C power IC that's responsible for powering the board on. We do not have a circuit diagram for this board. We do not have a board diagram for this board, but we can use common sense to figure out where those ICs are. Both ports should have similar circuits and ICs. I currently have the Barlow lens on because I want to see more of the board rather than zoom in. And we have a customer. One moment.
Yeah.
Hi, how are you?
How are you?
What's going on?
My cell phone, it's broken.
Now, since we have two USB-C ports on here, we should have two USB-C power ICs on the board. And usually with the power ICs, we have diodes. So these are the two USB-C ports here. I do not see any physical damage onto the ports. And when I plug the cable, it plugs in just fine. So I do not think the problem is from the ports themselves. One port can go bad, but not both ports. A lot of people think that the charging port connector is what's bad. If we see physical damage onto the port, to the pins inside the port, then yes, it's a port issue. But since both of them are not working and both of them look good and the pins inside they look good, then there's no reason to think that the problem is from the ports. These are the power ICs. That's one of them here. And that's the other one. The other one is slightly discolored because look at this one. Look at how sharp and clear this chip is, and look at this one here. That doesn't really mean anything, but it's just first glance, that's what I see. This diode here doesn't look too good. It looks like it's out of place. I mean, it's solid, but this, the way it looks raises a question. Let me test this diode here to see if, so black probe here and red here. And the meter is given 0.568. Sounds reasonable. What about this one here? Whoa, short. We have a short. Okay, do we have a short on any of those caps? Just random check. Everything looks good. Okay, this cap is short. This cap may be shorted because of either the IC here . Okay, so those caps are good. So the only thing that's shorted is this capacitor on top here. We do not have any circuit diagram for this board. We do not have any board diagram for this board. So whatever we are doing, it's just based on our findings and common sense. Right now, this is the only capacitor that I tested short. The only thing that could short the circuit here is the IC itself, this capacitor, or even this chip. Let's remove this capacitor and see if we still have a short. And if we test now, do we still have a short? If we still have a short, then the problem is not the capacitor. And the problem is not the capacitor. The MOSFET could be causing a short as well. Let's test this capacitor, this capacitor. There's no short here. It looks like the USB-C power IC is what's causing the short. And maybe that's why it looks discolored. I mean, look at the difference between this and this chip. Since the diode has a short and there's a capacitor on top that also has a short, chances are the USB-C power IC is what's causing the short. So what I want to do, since we have two USB-C charging ports, I want to know which chip belongs to which port. Let's go to our thermal cam. I'm going to plug the charging cable in and then monitor the board under the thermal cam to see which IC gets hot. If we plug the cable in USB-C port 1 and chip number 2 turns on, it means that that port belongs to that chip. I'm going to plug the cable in port number 1. Port number 1 is not heating anything up on the board. Nothing at all. Plug the cable in port number 2. And look at that. So this chip belongs to port number 2. Let's remove this USB-C power IC for USB-C port number 1. This is what's probably causing the short. And I'm going to go ahead and remove it, just for the sake of seeing if this will clear the short. Okay, and now let's test to see if the short is gone. It makes sense that this IC is causing the short. So meter in diode mode, red probe on ground, and test here. And look at that, the short is gone. This side is ground and this side is no longer beeping, so the short was caused by the chip. The board turned on. Look at the light. Now we can make port number 1 work if we replace this chip. So all we have to do is buy another chip, put it in, and port number 1 should work. For now, port number 2 is working and the job is done. The board is working now on just port number 2. If we want to fix port number 1, we would have to get the USB-C power IC. We do not have one in stock, but at least the board is fixed and working now. I hope you enjoyed the video. Don't forget to subscribe and we'll do something else in the next video.